So we're here in Coal Creek right now in part of a coniferous forest. It's a part of our study with Dr. Lely out of Penn State as well. I'm Pam Sullivan out of Oregon State. Part of the question we're asking is what are the differences and the impact of different vegetation types on some of the concentration discharge behaviors that we might see. So we're installing a set of sensor arrays across different vegetation types. That's why we're here in the conifer forest today. So here we're going to have an array of four different sensors at 3 different depths. So the first kind of sensor we have is just a typical matrix potential sensor. The second kind of sensor we have is going to give us soil moisture, soil temperature, and electrical conductivity. Then finally we're also going to use, I guess, the apogee sensor, which is for looking at oxygen concentrations. And then we finally have the CO2 sensor by EOSense, which gives us CO2 concentrations rated up to 60,000 ppm. So with this slew of different probes that we have here, not only can we get an idea of the hydrology of the system, but we actually can get a really great idea of the biogeochemistry of the system. If you think about the idea of how oxygen and concentration are trade-offs, right, between respiration and decomposition that's taking place in these systems, we can begin to understand what are the processes governing the CO2 and O2 concentrations at depth. And then work with Dr. Lely and her student Devin are going to give us an idea of the chemical weathering processes that can take place in them as that CO2 interacts with water to create acid, and our oxygen can allow for, depending on what conditions we're in, oxidation of processes.